So, this is the last topic in solid state, density of ionic crystal. Okay. So, we know that density is equals to mass by volume, no? Density is equal to total mass divided by total volume is called as density. Okay. Now, I want to calculate density of this ionic crystal, cubic crystal. So, cubes we have studied, many types of cubes we have studied. Like we have studied PCC, primitive cubic cell. We have also studied about FCC, BCC, body centered cubic. So I want to calculate the density of all these crystals. Okay, ma? So we know that 1 molar mass is also called as molecular weight, no ma? 1 molar mass is also called as molecular weight. Now what is meant by 1 molar mass, ma? What is meant by molecular mass? So it is the mass of 1 mole of atoms or molecules or ions or formula units. That's all, no? So mass of 1 mole of atoms, molecules, ions or formula units is called as molecular weight. Clear, no? That's all, no? Mass of these many atoms, these many molecules, ions or formula units. Now what is meant by 1 mole? Mole is a number, no? So therefore I can write mass of 1 atom or I can write mass of 1 molecule or mass of 1 formula unit, okay, ma? Multiplied by Avogadro number. Can I call it as molecular weight? Is it correct, ma? Mole means number, no? Which number? Avogadro number. Clear, no? So mass of 1 single atom or 1 single molecule or 1 formula unit multiplied by how many atoms or molecules or formula units? Multiplied by 1 Avogadro number, that is also called as molecular weight. Are you able to understand? Okay. Therefore, mass of 1 atom or mass of 1 molecule, ions also we can write directly. I am writing mass of 1 formula unit. That means formula unit. 1 formula unit, or just we will write 1 formula unit. How can I write? I can write molecular weight divided by Na. I can write like this, no? Molecular weight divided by Na. So just this Na I am sending to the other side. Are you able to understand? So until now what we have got mass of 1 atom or mass of 1 molecule or mass of 1 formula unit. NaCl, it will become 1 formula unit, no? NaCl, CSCl, all of them they will become 1 formula unit. Clear, no? So therefore mass of 1 formula unit I can write like this. But in an ionic crystal, how many formula units may be present? That depends upon the type of the unit cell, no? For example, if you take primitive unit cell. In a primitive unit cell, how many formula units will be there? Only 1 formula unit. What is meant by primitive unit cell? Atoms, they are present only at the corners. How many corners? 8 corners. What is the contribution? 1 by 8. 1 by 8 into 8 is 1. BCC, body centered cubic structure. So 8 atoms are present at the corners and there is 1 atom present at the center also. So totally formula unit is 2. Similarly, if you take FCC, 4. So like this, depending upon the type of crystal, Z value will change, no? Clear, no? So in an ionic crystal, Z formula units may be present. Z formula units may be present. Clear, no? For example, I will write for primitive unit cell or primitive cubic cell, Z value is how much? 1. For BCC, it is Z value is equal to 2. For FCC, it is Z value is equal to 4. Clear? Therefore, mass of unit cell, how can I write? Mass of unit cell, how can I write, ma? According to this formula, can you say, how can I write mass of 1 unit cell? Whatever may be the type of unit cell, PCC, BCC, FCC, how can I write? Anybody? చెప్పండి. I am discussing only about mass only. What is this one? This is mass of one formula unit. That's all, no? Or you can say mass of one atom, or you can say mass of one molecule. Okay. Now if I want to write mass of total unit cell, okay, mass of total unit cell I want to write down, then how can you write the equation for mass? Z, that's all. Clear, no? So this is the mass of one unit cell, no ma? How many unit cells may be there? One may be there, two may be there, three may be there, and more also may be there depending upon the type of unit cell. Clear, no? So therefore, mass of one unit cell is Z into mass of one formula unit. What is the mass of one formula unit? Molecular weight divided by Na. So this is the formula. Clear, no ma? So therefore, this is the mass of one unit cell. So if I calculate mass, can't I calculate density, mano? M value I have calculated, no? Volume. So can you say what is the formula for volume of a cubic cell, ma? Volume of a unit cell or a cubic unit cell. Volume of a cubic unit cell. Volume of a cube entara? A cube. Edge length we have taken A, no? So length is A, breadth is also A, depth is also A only. So volume is how much? Volume is A cube. Clear, no? So mass I have calculated, mass of unit cell, and volume of unit cell I have calculated. So density of unit cell, just divide both of them. Okay, ma? So therefore, density of unit cell is how much? So this is equals to mass by volume. That's all, no? What is the mass? Mass is Z into molecular weight divided by Na multiplied by what is the volume? A cube. That's all. This is my formula to calculate density of unit cell. Understood, no, ma? Is it clear how we have understood all this? So Z into molecular weight divided by Avogadro number multiplied by A cube. Okay, ma? So many times questions were given on this relation, ma. Okay? So write down, we will do one question on this, then you will understand. So this is the given question. So edge length of metal having molar mass 75 is 5 angstrom. Clear, no, ma? So therefore edge length means A only, no, ma? A is 5 angstrom. 5 angstrom, how can you write in SI system? 5 into 10 power minus 10 meters. But everything is given in grams per centimeter cube. CGS system is given, no, ma? So 5 into 10 power minus 10 meter will convert into 5 into 10 power minus 8 centimeters. This is how I can write down. Clear, no? Now see. So then edge length is given, then what is the molar mass? Molar mass is nothing but molecular weight is how much? 75. 75 means what? 75 means if you take a single molecule, then it is 75 AMU. If you take mole of atoms or mole of molecules, then it is grams. That's all, number. So molecular weight is 75 grams. Are you able to understand? Okay. Then it is crystallizing into a cubic lattice. So therefore, what is the formula for volume? Cubic lattice, no, volume is A cube, where edge length is A. And density is already given. What is the density of the crystal, ma? Density of the crystal is 2 grams per centimeter cube. This is the density of the crystal. Then you are supposed to find out what is the radius of the metal atom. So what is the radius of each atom which is present inside that crystal that I want to calculate? Anybody? How can I do this? Very good. First you calculate Z value. Clear, no, ma? Which is the formula I can use? Density is equals to Z into molecular weight divided by Na multiplied by A cube. This is the relation which I can use, no, ma? Density is already given, no? 2 grams per centimeter cube. Everything we are trying to calculate in CGS system only. So directly you can write a 2 here. How many formula units? I don't know. What is the type of unit cell? I don't know, no? Whether it is PCC, whether it is BCC, whether it is FCC, we don't know. So Z value just you can write like this. What is the molecular weight? 75. And it is given in grams only, no? So no problem. Divided by Avogadro number 6.023 into 10 power 23 multiplied by edge length. Edge length is how much? 5 into 10 power minus 8 whole cube. Are you able to understand now? So if I do this total calculation, then I will get Z value. Okay, ma? And Z value which you will get is 4. Do you know how I got 4, ma? Without calculation, how can I get 4? How I have written Z value is 4? Anybody can you say? Nobody? How I know that it is FCC? Huh? He did not give anything about percentages here. Huh? Z is equal to 4 I know because I know the answer, right? Z value is 4, that's all. Clear? Z value is 4 means this is what kind of unit cell? This is FCC, face centered cubic unit cell. So once I know Z value, then I can calculate R norma, because in FCC, okay, we have a relation, no, R is equals to A by 2 root 2 angstrom. Do you remember this one? So we have derived relations between radius and edge length in all types of unit cells, no? So in FCC, this is the relation. Do you remember this one? R is equals to A by 2 root 2. Then can't you calculate radius? That's it. So R is equals to, what is A value? 5. So 5 divided by 2 root 2. Just do this calculation. That is the radius of each atom present in this FCC. Understood, Nama? Let me see what is the answer. Congratulations, my answer is not given. So you do this calculation. So R is equals to 5 divided by 2 into root 2 is 1.414. Clear, Nama? 5 divided by 2.828. Do this calculation. That is the radius of this atom. Understood, no?